In this video, I am discussing KSET Mathematical Science previous year questions discussion. Topic: real analysis on sequence and series of functions. One announcement for you. ಏನಂದ್ರ ಬಹಳಷ್ಟು ಜನ ಡೌಟ್ ಕೇಳ್ತೀರಿ. ಒಬ್ಬರಿಗೆ ಇಬ್ಬರಿಗೆ ಅಂದ್ರೆ ರಿಪ್ಲೈ ಮಾಡಬಹುದು, ಎಲ್ರಿಗೂ ರಿಪ್ಲೈ ಮಾಡೋದು ಕಷ್ಟ ಆಗತ್ತ. ಆದ್ರಿಂದ ಡೈಲಿ ನಿಮ್ದು ಡೌಟ್ ಏನಿರುತ್ತಾ ಅದಕ್ಕಂತಾನ ಒಂದು ಕ್ಲಾಸ್ ಮಾಡ್ಬೇಕು ಅಂತ ಮಾಡೀನಿ. ಗೈಡೆನ್ಸ್ ಪ್ರೋಗ್ರಾಮ್ ಫಾರ್ ಕರ್ನಾಟಕ ಸ್ಟೇಟ್ ಎಲಿಜಿಬಿಲಿಟಿ ಟೆಸ್ಟ್ ಫಾರ್ ಅಸಿಸ್ಟೆಂಟ್ ಪ್ರೊಫೆಸರ್ಸ್ ಕ್ಲಾಸಸ್ ನಾಳೆಯಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತ. ಅಂದ್ರ ಬೆಳಗ್ಗೆ ಸಾಯಂಕಾಲ 7 ಗಂಟೆಯಿಂದ ಕ್ಲಾಸ್ ತಗೊಳುತ್ತ. ಟೈಮು ನೋಡೋಣ ಹೆಂಗಾಗತ್ತಾ, ಅದರಿಂದ ಫ್ಲೆಕ್ಸಿಬಲ್ ಟೈಮ್ ಎಲ್ರಿಗೂ ಅನುಕೂಲ ಆಗತ್ತಾರ ನೋಡ್ಕೊಂಡು ಮಾಡೋಣ. ಟಾಪಿಕ್ ಏನಂದ್ರ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನಾಲಿಸಿಸ್, ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಆಲ್ಜಿಬ್ರಾ, ರಿಯಲ್ ಅನಾಲಿಸಿಸ್, ಲೀನಿಯರ್ ಆಲ್ಜಿಬ್ರಾ, ODE, PDE, COV, IE, ನ್ಯೂಮರಿಕಲ್ ಅನಾಲಿಸಿಸ್. ಇವು ಎಲ್ಲ ಟಾಪಿಕ್ ಅನ್ನ ಆರ್ಡಿನರಿ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್, ಪಾರ್ಷಿಯಲ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್, ಇಂಟಿಗ್ರಲ್ ಇಕ್ವೇಶನ್, ನ್ಯೂಮರಿಕಲ್ ಅನಾಲಿಸಿಸ್, ಟೋಪೋಲಜಿ ಇನ್ನು ಬರ್ತಾವಲ್ಲ, ಅವನ್ನೆಲ್ಲ ನೋಡೋಣ ಅಂತ. ಅಂದ್ರ ನೀವು ಇವನ್ನೆಲ್ಲ ಟಾಪಿಕ್ ಅನ್ನು ಟೈಮ್ ಕೊಡುತ್ತ. ಒಂದೊಂದು ಎಲ್ಲವನ್ನು ಕವರ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಇನ್ನು ಈಗ 2ನೇ ತಾರೀಕಿಗೆ ಎಕ್ಸಾಮ್ ಐತಿ. 2/11 ಎಕ್ಸಾಮ್ ಐತಿ ಅಂತಂದ್ರ ಇನ್ನು ಟೈಮ್ ಐತಿ. ಅಷ್ಟ್ರೊಳಗ ಯಾವ ತರ KSET ಗೆ ಪ್ರಿಪೇರ್ ಆಗಬಹುದು ಅನ್ನೋದನ್ನ ಕ್ಲಾಸ್ನೊಳಗೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ ಅಂತ. ಮತ್ತ ಅಲ್ಲೇ ನಿಮ್ ಡೌಟ್ ಏನೇನಿರುತ್ತ ಅದನ್ನೆಲ್ಲ ನಂಗೆ ಕಳಿಸಿದ್ರ ಆ ಕ್ಲಾಸ್ನೊಳಗೆ ನಾನು ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಪ್ರತಿಯೊಬ್ಬರದ್ದು ತಗೊಂಡು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಮತ್ತೆ ಇತರೆ ಏನಾದ್ರು ಹೆಲ್ಪ್ ಬೇಕಾಗಿತ್ತು ಎಕ್ಸಾಮ್ ರಿಲೇಟೆಡ್ ಅಂದ್ರು ಹೆಲ್ಪ್ ಮಾಡ್ತೀನಿ ಅಂತ. ಅಂದ್ರೆ ಈ ಪ್ರತಿಯೊಬ್ಬರಿಗೂ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಅಷ್ಟು ಜನ ಕೇಳ್ತಾರೆ, ಎಲ್ರಿಗೂ ರಿಪ್ಲೈ ಮಾಡೋದು ಕಷ್ಟ ಸಾಧ್ಯ ಆಗತ್ತ. ಹಂಗಾಗಿ ಈ ತರ ಯೋಚನೆ ಮಾಡೈತಿ. ಈಗ ಈ ಕ್ಲಾಸಿಗೆ ಜಾಯ್ನ್ ಆಗ್ಬೇಕಂದ್ರ ಟೆಲಿಗ್ರಾಮ್ ಗ್ರೂಪ್ಗೆ ಜಾಯ್ನ್ ಆಗ್ರಿ ಮೊದ್ಲ. ಆನಂತರ ಅದ್ರದ್ದು ಇನ್ಫಾರ್ಮೇಶನ್ ಎಲ್ಲ ಹೇಳ್ತಿದ್ದೆ. ಇದು ಕ್ಲಿಯರ್ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ತುಂಬಾ ಯೂಸ್ಫುಲ್ ಆಗತ್ತ ನಿಮ್ಗೆ, 100% ಯೂಸ್ಫುಲ್ ಆಗತ್ತ. ಇದ್ರ ಫೀಸ್ ಈಗ ಕಡಿಮೆ ಐತಿ. ಅಂದ್ರೆ ನಾನು ಇರ್ಲಿ ಅಂತಾನೆ ಕಡಿಮೆ ಇಟ್ಟೀನಿ, 2,000 ಅಷ್ಟ ಐತಿ. ಬಹಳ ಫೀಸ್ ಏನಲ್ಲ. ಜಾಯ್ನ್ ಆಗೋ ಇಷ್ಟ ಇರೋರು ಜಾಯ್ನ್ ಆಗ್ರಿ. ಕ್ವಶನ್ ನೋಡ್ರಿ. ಈಗ KSET 2024 ಕ್ವಶನ್: if series of fn of x converges uniformly to f on a set S, then options are fn converges to f pointwisely, fn converges to 0 uniformly on S. Second, fn converges to 0 on S but not uniformly. Fn minus f tends to 0 uniformly on S. ಈ ತರ ಆಪ್ಷನ್ ಐತಿ, ನೋಡೋಣ. Question based on series of function. Series of function definition is: if fn of x is a sequence of real valued function defined on interval I for all n belongs to n set of natural numbers n, then summation n is equal to 1 to infinity fn of x is equal to f1 of x plus f2 of x plus f3 of x and so on is called series of function on the common domain A. Here they given S, A, S or anything you want. Next, if Sn of x is the sequence of partial sum of the series summation n is equal to 1 to infinity fn of x, then if Sn of x, this is sequence of partial sum, Sn of x converges pointwisely or uniformly on the common domain A to its limit function s of x. That means here Sn of x converges to its limit function s of x. This. Then summation n is equal to 1 to infinity fn of x converges to s of x uniformly or pointwisely on the common domain A. And s of x is called some function of the series. Here in series, s of x is called some function. In sequence, this is called limit function. Difference between this in sequence and series is, in sequence it is called limit function. In series it is called sum function. Next, for the question result, let sequence fn be a sequence of functions on I such that I means interval. Limit n tends to infinity fn of x is equal to f of x, and let mn, this is supremum, mn is equal to supremum of modulus of fn of x minus f of x such that x belongs to I. Then fn converges uniformly on I if and only if limit n tends to infinity mn is equal to 0. This is the condition for convergence of sequence or series. Next, this is for sequence. Next, mn test or Weierstrass test for series. Let n is equal to 1 to infinity fn of x be a given series of functions such that modulus of fn of x less than or equal to mn for all x belongs to A, that means common domain. If the series n is equal to 1 to infinity mn is convergent, then n is equal to 1 to infinity fn of x converges uniformly on A. Yes, this is the result. That means mn limit n tends to infinity mn is equal to 0 or else tends to 0 as n tends to infinity. See the question now. Right option is here fn tends to 0 uniformly on common domain A. This is the answer. Simple result based question. Now next question. KSET 2020 question. Let fn from R to R be a differentiable for each n is equal to 1, 2, and so on with modulus of fn dash, means differentiation of fn of x less than or equal to 1 for all n and x. Assume limit n tends to infinity fn of x is equal to g of x. Then G is continuous for all x. G is continuous only for x greater than 0. G is continuous only for x less than 0. G is not continuous. Now, see the result. Concept is, let Fn of x be a sequence of differentiable function on a common domain A such that Fn converges pointwisely to f of x and Fn dash of x sequence Fn dash of x converges to g of x uniformly or pointwisely on A. Then f of x is also differentiable on A such that f dash of x is equal to g of x. Next, also Fn converges to f of x uniformly on A, that is Fn of x converges pointwisely or uniformly to f of x, then Fn dash of x converges to g of x. That means f dash of x here, differentiation of this is g of x converges uniformly or continuous function. Now, see the Fn dash of x less than or equal to 1 for all n and x. Assume that limit n tends to infinity Fn of x is equal to f of x we taken, here they taken f of g of x. Now, g is continuous for all x. This is because your differentiability implies continuous. We saw in LCD, means limit continuity differentiability problems. Differentiability implies continuity. Differentiability implies continuity. Continuity doesn't imply differentiability, but differentiability implies continuity because limit f dash of a is equal to limit n tends to infinity f dash of a is equal to f of x minus f of a divided by x minus a. This is definition for differentiability. Definition for continuity is limit n tends to infinity f of x is equal to f of a. That means f of x minus f of a less than epsilon. I already discussed this in LCD topic. Therefore, answer here is G is continuous for all x. This much for this video. I hope this is useful for you. If you like the video, hit the like button, subscribe this channel for more videos. If you want to practice more questions, join our Telegram group. In that, I post many questions to practice. Thank you.